Hello everyone, good afternoon. Welcome to MADE EASY's GATE 2026 Electronics and Communication Paper Solution. Myself Hanif, I'm here to discuss about control system questions. Prior to that, as per the discussions with the students, as per the data received, the overall approach of the overall paper, it seems to be some of the subjects are easy to moderate difficulty level and some subjects are of a bit difficult level. So overall, it's a mixed response as it usually is. So this year paper, it's not totally on the easier side. Some subjects easy to moderate and some subjects are of a difficult level. In control system, questions are of moderate level. We received data of 5 questions. There may be more, but we got 5 questions data. So let us look at those 5 questions one by one. This question, which is a classroom question, workbook question, and appeared once in the previous papers as well. The structure is same, but different data it was. These two blocks are in parallel because their input is same and their output is being merged. So the outcome here is going to be 0 because these two are in parallel. So this will make the feedback null and void. Hence the answer to the question is directly 1 by s plus 4. So transfer function is directly 1 upon s plus 4. That's simple it is. We can also apply Mason formula, but unnecessary. In this question, we have to find the transfer function, and this is not of any standard form. So we have only one formula left. We have only one procedure left. C Si minus A inverse into B plus D. This is the formula to find the transfer function from state model. This is A matrix. This is B matrix. This is a C matrix and a D matrix being 0. So upon substitution and solving this transfer function comes out to be, after all the calculations, the transfer function becomes 3s plus 5 upon s square plus 4s plus 6. This is what we get after calculation. Yeah, that's good. Someone is waiting since 1 p.m. but we have planned it at 3 o'clock. Yeah, it is the same answer. That's correct. Good. Next, we have got this block diagram. Question is to find the value of K for marginal stability. Find the value of K for the system to be marginally stable. Obtaining the characteristic equation of the system, that characteristic equation becomes s cube plus 18 so square plus 77s plus k is equal to 0. This is the characteristic equation. And we know, as usually in the third order system, for a system to be marginally stable, product of these coefficients must be equal to product of these coefficients. So K becomes 18 multiplied by 77, which is 1386. But this is the value of K for which the system becomes marginally stable, as per the question. Right? $18 multiplied by 27 कर दिया, 77 के बदले सचिन तिवारी. Oh, mistake हो गया आपका. Next, in this question, we have got a block diagram where this controller block is given to be Ks plus alpha. This plant is given to be 1 upon s plus 1 s plus 2. The question says that the closed loop poles have to be located at minus 3 plus r minus j root 5. Find the value of K and alpha. Obtaining the characteristic equation of the system to be 1 plus K s plus alpha upon s plus 1 s plus 2. So that characteristic equation is going to be s square plus s k plus 3 plus alpha k plus 2 equal to 0 is the characteristic equation. Now, According to the location of the poles, that characteristic equation should be s plus 3 square plus root 5 square is equal to 0, which becomes s square plus 6s plus 9s plus 5 4 is equal to 0. So k value becomes 3 upon comparison, and alpha value becomes 12 by 3, 4. So the value of alpha is 4 and the value of k is 3. Yeah, that's good. Also getting the same thing. Next, this is the last question that we have got. We have got the state model of the system. This is homogeneous state equation. This is initial condition vector. And this is a solution of that homogeneous state equation. Question is to find the value of A. It's very simple. See, this is one pole, this is another pole. The eigenvalues, the closed loop poles, one is this, the other is this. So the two eigenvalues, as can be directly seen from the response. So either the A matrix has to be 1, 0, 0, minus 2, or that A matrix has to be minus 2, 0, 0, 1, or if I write the characteristic equation, it will be s square plus s minus 2 equal to 0. Right? S square plus 2 minus 2. So the A matrix can even be 0, 1, 2, minus 1. Right. So either if this is found in the options, we can take this or this or this. So I see that it is option A that you get. Yeah, that's all about the questions regarding control system. I think you all might have done the same thing. Next subject follows. Thank you.
Hello dear students, I am Iftikhar Ahmed and I have Rajkumar sir also with me, and we will be discussing questions from analog circuits that have come in today's electronics gate paper. And as per the data we got from students, we received about 6 questions, and there are like 3 questions on op-amp.
3 questions on
and
op-amp.
1 question op-amp with BJT,
Yeah,
1 MOSFET question,
and
one
one diode question.
diode question is. Yep.
But this time the questions are looking very easy and
Yes,
comfortable.
in analog, I think questions are on the easier side.
Maximum students have done it. I'm
I
expecting.
think the
from
feedback that we got from students is some subjects on the difficult side and some are
Some
like
are-
easy to moderate,
Yeah.
and analog is slightly on the easier side. Okay.
Yeah.
I will be discussing few questions and sir will also take up some questions.
Yeah.
So let us see the first question, dear students. ये था पहला वाला question. It is based on op-amp, and there is a switch shown here. When switch open, this op-amp is giving output x volt. Okay. When switch open, output is given x volt right here. Then output equal to x volt. Let us calculate this output quickly. When switch open, these two resistors will come in series. It will become 3K. and it is just like a non-inverting type amplifier. We can treat it as a non-inverting amplifier, and we'll be getting output, let me call it V01. It will be 1 plus that R2 by R1 into Vi formula apply करेंगे हम. So these two resistors in series, it becomes 3K. So V01 will be 1 plus 3 divided by 1. So input is given 1 volt. So this will become like 4. This can be taken as X. This 4 volt is equal to X as per the data given. And then if the switch closed, अगर हम switch को यहाँ पर close करेंगे बेटा, तो ये वाला resistor dead हो जाएगा. When switch closed, I mean it's like a short circuit in parallel to resistor, then this 1K will become dead, only 2K will remain. Let me write here, switch closed. If switch closed, we will be getting output, let me call it V02. It will be 1 plus 2 by 1 into 1 volt. This is like 3 volt is becoming. Now we have to find V02 in terms of X. Okay, तो अगर हम रेशियो लिखेंगे V02 upon V01, so it will become V02 divided by V01. It will be 3 by 4, right? 3 divided by 4, or we can say V02 equal to 3 by 4 into V01. That V01 we can put as X volt. So this will become 3 by 4 into X. So in this question, the answer will be 3/4 of X. Then the next question, I think Rajkumar sir will take up. So please.
So this is about op-amp with BJT question. This we'll see now. Generally what we do in this question is first make the BJT as cutoff. When you open this, then the op-amp 3 volts is there, that side, plus side. This side will get 0. So 3 and 0 will be compared by using comparator concept, so that we are getting here plus Vsat, because of plus is dominating the minus. Because of plus Vsat, this transistor will be on. So we can confirm by saying that your transistor is working in active region. So when it works in active region, it's a closed loop analysis we can take here, where this negative has become a feedback to this transistor at emitter side. At emitter side we don't have 180 degrees phase shift, so it is a negative feedback system. So that confirms me that if I take this as V plus and this as V minus, we can use virtual short theory, V plus is equal to V minus, so that the 3 volts will come here. So 3 will get emitter current here, which is 3 by 1K, which is coming 3 milliamps. So this completes IE current 3 milliamps, but the question here is I naught, is here IB. Is asking IB current, not IE current. According to the BJT transistors, we have a formula IE by 1 plus beta is IB, which is nothing but I naught. So IE current here is 3 milliamps divided by 1 plus beta is 99. So it will become 3 milliamps divided by 100. Okay, I think the expected calculation value here.
0.03 ampere.
Okay, 30 microamps.
Microampere.
So we are expecting 30 microamps will be the correct answer for this. The next question Hiftikar sir will take.
This was a question about finding this current Ix. Okay, it's a negative feedback op-amp circuit, and we can treat this like a inverting type amplifier, and we can directly calculate output voltage. Output not is equal to minus R2 by R1 into input. Okay, minus 1 by 1 into input is 2 volt. So this is like minus 2. We are getting output voltage of the op-amp minus 2 volt, and we have to calculate current Ix. तो अब हम ये करेंगे बेटा कि हम यहाँ पर करंट फाइंड करेंगे इन दिस रेजिस्टर to have minus 2 volt present here, and this is like virtually grounded. So current will be flowing in this direction, and this current will be 0 minus of minus 2, that will become 2 volt. 2 divided by 1, current is equal to 2 by 1, that is like 2 milliampere. Resistor is in kilo ohm, and we can find current in this path also. Current will be like upward direction, so this is a negative voltage. This will be 0 minus of minus 2 divided by 2, it's like 2 by 2, 1 milliampere. Then apply simple KCL 1 milli plus 2 milli, that will flow as Ix. तो अगर आप यहाँ पर KCL अप्लाई करेंगे तो Ix equal to that 2 plus 1, that is 3 milliampere. So in this question Ix will be 3 milliampere. Okay, it's an easy question. I hope everybody has done it correctly. Then there was one question based on MOSFET. Okay, it's a MOSFET DC analysis question. We have to calculate here gate voltage. How much will be the voltage between gate and ground? Now as you can see, drain shorted to gate hai beta. If drain and gate are shorted, we can consider MOSFET in saturation region. Okay, whenever drain gate shorted, MOSFET will operate in saturation region. So what we will do is, we will first of all indicate here current. This is like drain current of the MOSFET. This will be VDS, and this voltage we can show as VGS. Now because gate and drain are shorted, that VGS will be equal to VDS. You can write VGS is equal to VDS, and VDS can be written as 5 volt minus 1k into ID. 5 minus 1k into ID. I have written resistor in kilo ohm, so we will get current in milliampere. So from here we can say drain current equal to 5 minus VGS. Let us take it as equation number 1. Then we can apply the current equation of MOSFET. When a MOSFET is in saturation region, drain current given by N0x divided by 2 into W by L into VGS minus V whole square. We can substitute here in place of drain current 5 minus VGS. 5 minus VGS equal to this parameter given 1 milliampere. This is as per the data we received. This is like 1 milliampere per volt square, 1 divided by 2 into VGS minus threshold voltage given 1 volt whole square. This we can simplify now. It will become 10 minus 2 VGS equal to A minus B whole square, that is like VGS square plus 1 minus 2 VGS. Now from both the sides 2 VGS वाला term cancel हो जाएगा, and we get VGS square equal to 9. So I will be getting here VGS equal to plus 3 as well as minus 3. We can ignore minus 3 because VGS should be a positive value here. VGS should be greater than threshold voltage. So in that way the correct VGS will be 3 volt. Now gate voltage, it will be same as VGS only. So we can say finally VG equal to VGS, and that is equal to 3 volt. So in this question gate voltage will be 3 volt. Then there are some more questions which Rajkumar sir will discuss.
Yeah, thank you, sir. So the next question is related to a diode concept. You can see one diode is in downward here, one diode is in upward. It's a clipper type of question, and he's asking the question, what is the maximum V naught? Whenever they ask you maximum V naught, diode downward direction diode will be on, because 2 volts above we are giving, which is the maximum voltage is 6 here. So we'll take a maximum voltage here, 6 volt is the maximum peak voltage, such that this diode will be taken as open, and this diode will become short here, V1. So the circuit looks like this. If you want to get V naught max, this answer if you want, the only thing is first I'll find out the current in this loop, I. So I into some 10k plus 2 volts. This will be the answer, V naught max. But to find out the current, we can have this loop, we'll get the current. So how much I got this current is, yeah, that is 0.2 milliamps into 10k plus 2. So this will be the value by taking the calculation 6 minus 2 divided by 20k. We are getting 0.2 milliamps into 10k plus 2, which is nothing but 2 plus 2, which is nothing but 4 volts. So the maximum voltage for this problem is 4 volts. One of the easiest question I am expecting. If they ask you V naught minimum, we have to go for D2 on, and we have to do the problem. So for this the answer is 4 volts. The last question we are dealing, I think, is a very popular circuit. It's called op-amp with the T network feedback, and it's a 1T network. Generally, if you can remember the formula, we can do directly, otherwise we have to use nodal analysis we have to do. So, we have a standard formula also for this. So, everything is 50K here. First I will substitute 50K, 50K, 50K and 50K. Okay. Generally we can apply this points, nodal points, and we can solve. If I have a standard formula, it is very easy to solve it. This is R2, this is R1. I will take this as R3 and this as R4. The standard output for this at T network feedback is V0 is equal to gain is expecting, so V0 by Vn is equal to minus R2 by R1 into 1 plus R3 by R2 plus R3 by R4. So, this result you can expect when you use virtual short theory concept. We can find out this answer. If you have standard formula with you, you can do very fast like this. 50K minus 50K by 50K plus 1 plus 50K by 50K plus 50K by 50K. Everything they have given same resistor, so it is very easy in calculation. It is minus 1 into 1 plus 1 plus 1. So, the answer will become minus 3. So, we got for this problem it is minus 3 we got. If suppose in the exam if they ask you in modulus, the answer will be gain modulus. If you take, the answer will be 3 is the correct answer. If they do not ask modulus, the answer will be minus 3.
So dear students, these were the questions from analog, and they were on the easier side, and we hope you all have done them correctly.
We are very happy that
Yes,
whatever we thought, everything came in a proper manner.
Yes, yes.
Thank you so much. Thank you. Yeah.
Dear students, I will now take up questions from EDC. We got around 5 questions from EDC which we received, and I think there was one more question which we could not gather. So यहाँ पर हमें data available है for 5 questions. I will be discussing those 5 questions, and they were like easy to moderate type. Let us see the question number 1. This was about calculation of diffusion current density. It's a question from semiconductor basics, and I hope everybody has done it correctly. अगर आप डेटा पढ़ेंगे बेटा तो it says in a semiconductor doping concentration linearly varies from 2 into 10 per 17 at x equal to 1 micrometer to 1 into 10 per 16 at x equal to 4 micrometer. There is a linear decrease in doping concentration. So this is a case of concentration gradient. It will give rise to some diffusion current, and that we have to calculate here. And some more data is given. Mobility question में given था 1400 centimeter square per volt second and thermal voltage 25 millivolt at 300 Kelvin. तो हम पहले यहाँ पर diffusion constant find करेंगे. Whenever we calculate diffusion current density, we should know diffusion constant. Okay. So first I will write here diffusion constant. उसके लिए हमें Einstein वाला relation use करना होगा. Einstein relation Dn by mu n equal to thermal voltage. So from here we get diffusion constant Vt into, can substitute here Vt 25 millivolt and mobility 1400. जब आप multiply करेंगे बेटा तो it will become 35 centimeter square per second. Then we will calculate concentration gradient. Let us write concentration gradient dN by dx, or we can write delta n by delta x. Delta n divided by delta x. Delta n will be 2 into 10 power 17 minus 1 into 10 to the power divided by delta x. How much is delta x? It is 4 minus 1 यानी कि 3 माइक्रोमीटर. उसको हम सेंटीमीटर में कन्वर्ट कर लेंगे. 4 minus 1 3 माइक्रोमीटर, एंड 3 माइक्रोमीटर विल बी 3 into 10 power minus 4 सेंटीमीटर. मैंने डेल्टा एक्स को सेंटीमीटर में पुट किया है बिकॉज हमारा न्यूमरेटर सेंटीमीटर में है, राइट. 1 माइक्रोमीटर इज इक्वल टू 10 power minus 4 सेंटीमीटर. So this you can calculate. It will become some 6.33 into 10 to the power 20, and this is in centimeter to the power minus 4. Concentration gradient. Next we will apply diffusion current density formula. J diffusion is equal to, it will be q into dn into dn by dx. You can substitute electron charge 1.6 into 10 to the power minus 19, diffusion coefficient 35, and concentration gradient 6.3 into 10 to the power 20. When you multiply this beta, you will get current density 3547 एम्पियर पर सेंटीमीटर स्क्वायर. अब हमें इसको मिलीमीटर स्क्वायर में कन्वर्ट करना होगा. दे हैव आस्क्ड वैल्यू इन मिलीमीटर स्क्वायर. हमने वैल्यू फाइंड किया है इन एम्पियर पर सेंटीमीटर स्क्वायर. अब ये सबको पता है 1 सेंटीमीटर इक्वल टू 10 मिलीमीटर, राइट, एंड 1 सेंटीमीटर स्क्वायर इट विल बी 100 millimeter square. You have to remember this conversion. 1 centimeter equal to 10 millimeter, and 1 centimeter square it will be 100 millimeter square. तो वो चीज़ आप यहाँ पे पुट करेंगे बेटा, तो करंट डेंसिटी इट विल बिकम 3547 एम्पियर पर सेंटीमीटर स्क्वायर. सेंटीमीटर स्क्वायर को हम लिख देंगे 100 millimeter square. Hope you understood the conversion. 1 centimeter square it will be 100 millimeter square, and this will become 35.47 ampere per millimeter square. So in this question the correct answer will be 35.47 ampere per millimeter square. I hope you all have done it correctly. Let us go to next question. The next question is based on BJT early effect concept. Okay. There are two graphs given corresponding to two different BJTs. This curve 1 it is corresponding to some, let us say, BJT 1, and this is corresponding to BJT 2. अब हमें दोनों का अर्ली वोल्टेज कंपेयर करना है बेटा, and this was given as a MSQ. I think it was given as MSQ. You know this concept. When we project these graphs backward, we will get one intersect. That intersect will provide us अर्ली वोल्टेज. ओके, अब यहाँ पर होता ये है कि जिस ग्राफ का स्लोप कम होगा वहाँ पर आपको अर्ली वोल्टेज ज़्यादा मिलेगा. ओके, विच एवर कर्व हैज़ लेस स्लोप देयर द अर्ली वोल्टेज विल बी ग्रेटर. ओके, तो अगर आप स्लोप कंपेयर करेंगे, ग्राफ थोड़ा ठीक से ड्रॉ नहीं किया हुआ है, इट वाज लाइक दिस एंड दिस वाज सम ग्रेटर स्लोप. वन स्लोप वाज less, another slope was greater. I am assuming here BJT 2 has lesser slope and BJT 1 has greater slope. Okay, तो BJT 2 का अर्ली वोल्टेज स्लोप बेटा यहाँ पर कम है, तो इसका अर्ली वोल्टेज ग्रेटर होगा. VA2 ग्रेटर देन VA1, मॉड VA2 ग्रेटर देन मॉड VA1. जहाँ पर आपको स्लोप कम दिखाई दे उस वाले BJT का अर्ली वोल्टेज ग्रेटर होगा. okay, तो BJT 2 has lesser slope, तो BJT 2 will be having greater early voltage. VA2 greater than mod VA2 greater than mod VA1. Let us now look at the statements. Statement 1 will be wrong because VA1 actually less than VA2 है. VA1 infinitely large, ये भी गलत है. दोनों BJT के लिए यहाँ पर early voltage finite होगा. Early voltage becomes infinite when the slope is 0. Remember, अगर slope 0 है then early voltage will be infinite, लेकिन यहाँ पर slope non zero है तो both BJTs will have finite early voltage. So in that way B option wrong है and VA2 finite ये सही मानेंगे हम and VA1 less than VA2 ये भी सही है. So in this question these options were correct. Okay? Option C and D are the correct answer. So this was question about BJT early effect. Let us go to next problem. This is based on PN junction diode. There is a PN junction with a forward bias 2 volt. Then what will be magnitude of difference between the quasi Fermi level EFP and EFN? Okay, Fermi level of the P side and Fermi level of N side. This is simply property based question. And as everybody knows, when a PN junction is in equilibrium, यानी कि अगर हम कोई voltage apply नहीं करेंगे, and if PN junction is in equilibrium, then EFN, EFP, they will be like aligned. Okay, they will be in line. When PN junction is in equilibrium, Fermi level of the P side, N side, they will be aligned. They will be at same level. लेकिन जब हम external voltage apply करेंगे, then the Fermi levels will be at different positions. And that difference will be equal to the applied voltage in electron volt. तो अगर हम यहाँ पर difference लिखेंगे, it will be 2 electron volt. अगर हम 1 volt apply करेंगे तो दो फर्मी लेवल का डिफरेंस 1 EV के बराबर हो जाएगा. अगर आप 2 वोल्ट अप्लाई करेंगे तो दोनों फर्मी लेवल का डिफरेंस 2 इलेक्ट्रॉन वोल्ट के बराबर होगा. ओके, रिमेंबर फर्मी लेवल इज एनर्जी, इट विल बी इन इलेक्ट्रॉन वोल्ट. So in that way we can take answer as 2 electron volt. Hope you got the idea. When PN junction is in equilibrium, then EFP, EFN, they will be in line. If you apply external bias, then they will be at different levels, and that difference will be equal to 2 electron volt. You can take answer as A option. Next, this is question about Zener breakdown. In PN junction diode, we have two types of breakdown, right? Avalanche breakdown and Zener breakdown. Avalanche breakdown happens because of collisions, okay, because of collisions of high energy carrier with lattice atoms, that is avalanche breakdown. And Zener breakdown happens because of strong electric field, we call it field ionization also. Zener breakdown is due to strong electric field of the order megavolt per centimeter, which causes rupture of covalent bonds, and we call it field ionization also, and that we can relate to tunneling. Okay, remember Zener breakdown will happen because of tunneling. In normally Zener breakdown happens in heavily doped diodes. In heavily doped diodes, that depletion width will be very narrow, and because depletion width very narrow, electrons can tunnel, okay, from one side to another side. So Zener breakdown is mainly because of tunneling. So we can take answer as D option, electron tunneling. Then we have one more question. It is about related to photo devices or optoelectronics. Okay, a semiconductor has energy gap 1.3 electron volt. Then which of the following wavelength range will not be absorbed? के लिए हमें एक सिंपल फॉर्मूला यूज करना होता है. A wavelength is absorbed, a wavelength absorbed if that value less than or equal to 1.24 divided by Eg micrometer, then micrometer. This is the formula, तो सबको पता होगा. तो यहाँ पर हम एनर्जी गैप का वैल्यू पुट करेंगे बेटा 1.24 divided by 1.3. So I will be getting from here lambda less than or equal to, ये हमें कैलकुलेट करना होगा, you will get 0.953 माइक्रोमीटर. अब इसको हम नैनोमीटर में कन्वर्ट कर लेंगे, इट विल बी 953 नैनोमीटर. So we have to tell which wavelength will not be absorbed. अगर wavelength of the incident photon less than this, it will be absorbed. Remember, wavelength of the incident photons less than this, then that wavelength will be absorbed. And if this wavelength exceeds 953 nanometer, then that will be transmitted without absorption. Okay, we call it transparent behavior, right? If lambda, this is actually cutoff wavelength, इसको हम cutoff wavelength भी बोल सकते हैं, lambda c. When lambda less than this, that wavelength will be absorbed, right? And if lambda greater than this, that wavelength will not be absorbed. तो ये दो wavelength तो absorb नहीं होंगी बेटा. एंड डी। कमिंग टू ऑप्शन ए, ये अब्जॉर्ब हो जाएगा बिकॉज इट इज लेस देन 953। अब ऑप्शन बी में थोड़ा सा कंफ्यूजन आएगा आपको, क्योंकि 950 +-2 +-20 नैनोमीटर, तो यहाँ पर कुछ फोटॉन्स अब्जॉर्ब होंगे और कुछ अब्जॉर्ब नहीं होंगे बेटा। ओके, 950 +-20 यानी कि 930 से लेकर 970, वी आर टॉकिंग अबाउट 930 नैनोमीटर टू 970 नैनोमीटर। तो अब इस रेंज में होगा ये कि 930 से लेकर 953 नैनोमीटर, those photons will be absorbed, and 953 to 970, those photons will be transmitted without absorption. This is actually called opaque behavior. इसको हम कहते हैं opaque behavior. Some photons are absorbed and some photons are transmitted. तो अब यहाँ पर 930 से लेकर 953 नैनोमीटर, those photons will be absorbed, and 953 to 970 nanometer, they will not be absorbed. So that is a question mark about this range. Okay, I hope this data is correct. तो इसमें थोड़ा सा confusion आएगा, यहाँ कुछ photons absorb होंगे और कुछ photons transmit हो जाएंगे without absorption. Okay, let me just check the range. अच्छा, कुछ बच्चे बोल रहे हैं कि will not emit बोला था, कौन से photons? अच्छा, विच फोटॉन्स विल नॉट बी एमिटेड। अगर हम विल नॉट बी एमिटेड लेके चलेंगे तो उसके लिए हमें ऐसे प्रोसीड करना होगा बेटा, विल नॉट बी एमिटेड फोटॉन, दिस आई गॉट एज ए कमेंट फ्रॉम सम ऑफ द स्टूडेंट, फोटॉन विल नॉट बी एमिटेड। फोटॉन विल नॉट बी एमिटेड, इसके लिए हमें एमिशन वाला कॉन्सेप्ट अप्लाई करना होगा। रिमेंबर इन सेमीकंडक्टर्स, normally in LEDs, whatever photons emitted, their energy will be greater than or equal to, okay, this is like emitted photons. Condition for emitted photons, they will have energy greater than or equal to energy gap. अगर हमें condition लिखना हो will not be emitted, then it will become H into F less than or equal to Eg, or H by lambda less than or equal to Eg. Condition for not emitted, this condition for emitted, this condition for not emitted. अगर आप इसको rearrange करेंगे बेटा तो it will become Hc by Eg less than or equal to lambda, और lambda greater than or equal to Hc by Eg को अगर आप कैलकुलेट करेंगे it will become lambda more than or equal to 1.24 by Eg, और Eg 1.3 गिवन था, तो वहाँ से कंडीशन कुछ ऐसा बनेगा, lambda more than or equal to 950 nanometer. These photons will not be emitted. Okay, emitted photons, they will have a wavelength less than 953, and photons of this much wavelength will not be emitted. तो अगर आप इस तरह से सोचेंगे तो अगेन सी और डी मैच करेगा, बिकॉज इन ऑप्शन सी एंड डी these are like greater than 953, so these photons will not be emitted. Okay, these photons will not be emitted, so better option is C and D. इस रेंज में कुछ फोटॉन्स एमिट होंगे बेटा 953, राइट, तो इस रेंज में कुछ फोटॉन्स एमिट होंगे, तो और ये तो डेफिनेटली एमिट होंगे, तो आप ये कह सकते हैं कि सी एंड डी विल बी अ बेटर ऑप्शन। सी एंड डी इज ए बेटर ऑप्शन हियर। एनीथिंग ग्रेटर देन दिस विल नॉट बी एमिटेड, okay, less than this those photons will be emitted, and greater than this those photons will not be emitted. So in my opinion C and D is a better option for this question. So these are the questions from EDC that we got, dear students, and I hope you have done them correctly. Please wait for the next subject. My best wishes to all of you.
Hi, good afternoon, friends. I am able to get only one question from the English part, that is based on vocabulary. Find the antonym of the word nocturnal. Those of you who attended my classes might have heard one thing. I taught image based vocabulary and I gave you the list also through my website. Image based vocabulary, right? I showed you noxious, a word called noxious. Okay, there is a cobra, noxious, dangerous. The root here is NOC, NGC, NOX, which means harm. Nocturnal is one of the derivatives of this particular root, right? Noxious, obnoxious, innocuous, internecine and nocturnal. These are the derivatives of this root. Nocturnal means people who are active, things that are active in the night, passive in the day. There are two kinds of human species. All of us, the humans, are diurnal. We are active daytime and we take rest in the night, right? And there are certain species like owl, bat, right? They are active in the night. Species which are active in the night are called nocturnal. The root here is NOC, right? Now we need the opposite of it. Normal ka opposite abnormal, exception is completely out of the context. So what is left is the answer, diurnal. Diurnal means those who are active in the day, which is the opposite of nocturnal. That's the only question that was available. I don't know if some more questions have been asked. That's it. My dear friends, hope you have written the exam very well. Best of luck. Please wait for the next subject.
ओके हेलो एवरीवन, तो माई सेल्फ रोहित त्रिपाठी और मेरे साथ नवीन सर हैं। हम लोग मिल करके अभी सिग्नल के क्वेश्चन सॉल्व करेंगे। आप लोग ज्वाइन किए रहिएगा। और सुना है कि आपने ही बोला है कि सिग्नल्स के बहुत सारे क्वेश्चंस आए हैं, अदर सब्जेक्ट्स के भी आए हैं, तो वन बाय वन देखते हैं। मेमोरी बेस्ड क्वेश्चंस हैं, तो हो सकता है डाटा थोड़ा सा मिसमैच भी हो सकता है, तो उसके लिए हम कुछ नहीं कर सकते। मेरे पास जो डाटा आया है मेडी जी के पास, वही हम लोगों ने डिस्प्ले किया है, उसके अकॉर्डिंग सॉल्व करेंगे। So this is first question. If xt has energy E, then the ratio of energy of xt divided by energy of 3x minus 3t plus 5 will be. तो हमें रेशियो कैलकुलेट करना है, ठीक है। सबसे पहले xt का एनर्जी कितना गिवन है, व्हाट इज द एनर्जी ऑफ xt E, ओके। व्हाट अबाउट एनर्जी ऑफ x of t plus 5, x ऑफ टी प्लस 5 का भी एनर्जी कितना होगा E, क्योंकि एनर्जी कैलकुलेशन टाइम शिफ्टिंग से इंडिपेंडेंट होता है। इसके बाद अगर देखें तो x ऑफ माइनस 3t प्लस 5, इसके लिए एनर्जी आप क्या लिखेंगे, E/3। कैसे? क्योंकि अगर ए से टाइम स्केल करते हैं तो एनर्जी को डिवाइड करते हैं मॉड ए से। यहाँ पर ए कितना है बेटा -3, तो E बाई मॉड -3 कितना होता है? E/3 होता। फिर आपने मल्टीप्लाई किया 3 से, 3x ऑफ -3t प्लस 5, तो प्रीवियस एनर्जी को क्या करोगे? प्रीवियस एनर्जी को 3 स्क्वायर से मल्टीप्लाई करोगे। एक चीज याद रखना, अगर आप सिग्नल को कांस्टेंट के से मल्टीप्लाई करते हैं तो प्रीवियस एनर्जी को मॉड के होल स्क्वायर से मल्टीप्लाई करते हैं, ठीक है। यहाँ कांस्टेंट के की वैल्यू कितनी है? 3, तो प्रीवियस एनर्जी को मॉड 3 होल स्क्वायर से मल्टीप्लाई करते हैं, मतलब 3 स्क्वायर से। तो अब क्या होगा? 3 से स्क्वायर कैंसिल आउट होगा, तो कितना आया? 3e। तो हमने देखा सिग्नल xt, इसका एनर्जी यही लिख देता हूँ, xt का एनर्जी कितना? e, और एनर्जी ऑफ 3x ऑफ -3t प्लस 5, एनर्जी कितना? 3e। तो बेटा रेशियो कितना आया? 1/3। कौन सा ऑप्शन करेक्ट है? ऑप्शन बी। आगे बढ़ते हैं, देखते हैं नेक्स्ट क्वेश्चन क्या है। आप लोग सारे लोग बने रहिएगा। तो विनोद, मीना, फिर सुशैन, फिर प्रवीण, फिर बहुत सारे बच्चे, ओके, आप लोग बने रहिए। सेकेंड क्वेश्चन है, इफ इनपुट आउटपुट रिलेशनशिप of the LTI system is this one, so difference equation of LTI system is given। क्या given है? yn is equal to 5/6 y of n minus 1 minus 1/6 y of n minus 2 plus x of n। तब अब सिस्टम इज, अब यहाँ पर 4 ऑप्शंस है एंड दिस क्वेश्चन इज MSQ। एक चीज ध्यान रखिएगा, ये जो क्वेश्चन है MSQ है। तो सिस्टम स्टेबल होगा इफ कॉजल, अनस्टेबल होगा इफ एंटी कॉजल, स्टेबल होगा इफ नॉन कॉजल, अनस्टेबल होगा इफ नॉन कॉजल। तो इसमें हम लोग क्या करेंगे बेटा? ट्रांसफर फंक्शन कैलकुलेट करेंगे। तो इस पर z ट्रांसफॉर्म अप्लाई करो। आप क्या लिखते? बाई z इज इक्वल टू 5/6 z इनवर्स बाई z, फिर क्या लिखते? -1/6 z की पावर -2 बाई z प्लस क्या लिखते? x ऑफ z। अब यहाँ से डायरेक्टली h ऑफ z पर जाते हैं। व्हाट इज h ऑफ z? रेशियो ऑफ बाई z एंड x ऑफ z। यहाँ से रेशियो लीजिएगा तो क्या आएगा? 1/1 माइनस 5/6 z इनवर्स। ये जो बाई z वाले टर्म्स हैं इसको LHS में लेकर के आना है, तो ये वाला टर्म प्लस में आएगा 1/6 z की पावर -2। फिर आप क्या लिखते? 1/1 माइनस 1/2 z इनवर्स इंटू कितना? 1 माइनस 1/3 z इनवर्स, ठीक है, ये इस फॉर्म में आता। फिर यहाँ से आपने पोल लोकेशंस कैलकुलेट किए, तो पोल लोकेशंस आप लिखते हैं 1/2 एंड 1/3। फिर यहाँ से अगर आप ROCs लिखें, रीजन ऑफ कन्वर्जेंस, तो ROC फर्स्ट पॉसिबल ROC कितना है? यहाँ पॉसिबल ROCs बता रहा हूँ क्या क्या हो सकता है। फर्स्ट पॉसिबल ROC होगा इनर मोस्ट सर्किल के इनसाइड, मतलब 1/3 के इनसाइड। इसके अकॉर्डिंग अगर आप HN लिखेंगे, क्योंकि ROC इनर मोस्ट सर्किल के इनसाइड है, तो इनवर्स कैसा लिखना पड़ेगा? लेफ्ट साइडेड। अच्छा, अगर आप पार्शियल फ्रैक्शन करते तो क्या लिखते? A/1 माइनस 1/2 z इनवर्स प्लस B/1 माइनस 1/3 z इनवर्स, इस फॉर्म में लिखते। सपोज A एंड B आर कांस्टेंट, जो कि कांस्टेंट है। A एंड B के वैल्यूज कैलकुलेट किए जा सकते हैं, बट कैलकुलेशन करने की कोई रिक्वायरमेंट नहीं है। आप यहाँ से अगर लेफ्ट साइडेड इनवर्स लिखते तो आप क्या लिखते? आप इस फॉर्म में लिखते -1/2 n u ऑफ -n -1 एंड कांस्टेंट A, ठीक है, यहाँ माइनस भी है। फिर -b इंटू क्या? 1/3 की पावर n ऑफ -n -1। अब इसको अच्छे से देखो, HN के सैंपल्स LHS में है, तो HN इज 0 फॉर n ग्रेटर देन इक्वल टू 0। और अगर HN n ग्रेटर देन इक्वल टू 0 के लिए 0 है, तो बताओ सिस्टम कैसा है? एंटी कॉजल है, ठीक है। और ROC इज नॉट इंक्लूडिंग यूनिट सर्किल, इसका मतलब सिस्टम कैसा है? अनस्टेबल है। तो सिस्टम एंटी कॉजल अनस्टेबल हो सकता है। तो हमें पॉसिबिलिटीज लेकर के चलने हैं, क्योंकि MSQ है तो एक से ज़्यादा ऑप्शन करेक्ट हो सकते हैं, एंटी कॉजल एंड अनस्टेबल। तो अनस्टेबल होगा सिस्टम अगर हम लोग क्या मानेंगे? एंटी कॉजल। नाउ सेकंड पॉसिबल ROC क्या हो सकता है? मॉड z बिटवीन 1/3 से कहाँ तक? 1/2 तक, ये होगा ना। अच्छा, अब इसमें HN कैसा लिखना पड़ेगा? बोथ साइडेड लिखना पड़ेगा। मैं HN को बोथ साइडेड अभी नहीं लिख रहा हूँ। क्यों नहीं लिख रहा हूँ? आप खुद सोचो, क्योंकि यहाँ से ROC का नेचर कैसा है बेटा? रिंग शेप का है। और अगर रिंग शेप का आरओसी है, रिंग शेप का आरओसी है, तो बताओ एचएन का नेचर कैसा होगा? बोथ साइडेड सिग्नल होगा। कैसा सिग्नल होगा? बोथ साइडेड सिग्नल। और अगर एचएन बोथ साइडेड सिग्नल है तो एचएन के सैंपल्स एलएचएस में भी नॉन जीरो है, आरएचएस में भी नॉन जीरो है। ठीक है, इसका मतलब जो एच ऑफ एन है वो नॉन कॉजल टाइप का सिस्टम है। तो एचएन के सैंपल्स एलएचएस आरएचएस दोनों में नॉन जीरो है, तो फिर सिस्टम कैसा होगा? नॉन कॉजल। और इस आरओसी में यूनिट सर्किट इंक्लूडेड नहीं है, इसका मतलब सिस्टम नॉन कॉजल है और अनस्टेबल है। नॉन कॉजल क्योंकि एचएन के सैंपल्स एलएचएस आरएचएस दोनों में है, अनस्टेबल इसलिए क्योंकि आरओसी में यूनिट सर्किट इंक्लूड नहीं हो रहा है। तो नॉन कॉजल होगा अगर अनस्टेबल है, तो नॉन कॉजल है इफ अनस्टेबल, डी भी करेक्ट है। और उसके बाद जो थर्ड पॉसिबिलिटी है, थर्ड पॉसिबिलिटी क्या? जब आप आरओसी लिखते मॉड z ग्रेटर देन 1/2 आउटर मोस्ट सर्किल के आउटसाइड, तो इस केस में आज आपको एचएन कैसा लिखना पड़ता? राइट साइडेड सिग्नल लिखना पड़ता। एचएन आप कैसा लिखते? राइट साइडेड सिग्नल लिखते। और अगर एचएन राइट साइडेड लिखोगे तो यहाँ पर एचएन मैं बोल देता हूँ कि क्या लिखते? एच ऑफ जेड है तो यहाँ से एच ऑफ एन आप लिखते ए इंटू 1/2 की पावर एन यू एन प्लस बी इंटू 1/3 की पावर एन यू एन, मतलब एचएन के सैंपल्स एलएचएस में जीरो आएंगे। तो फिर एलटीआई सिस्टम कैसा होगा? कॉजल होगा। और इस आरओसी में क्या इंक्लूड हो गया? 1 इंक्लूड हो गया। तो एलटीआई सिस्टम कैसा है? स्टेबल है। तो अगर आप इसको कॉजल मानेंगे तो ये स्टेबल होगा। तो एलटीआई सिस्टम अगर आप कॉजल मानेंगे तो कैसा होगा? स्टेबल होगा। तो इस एमएसक्यू क्वेश्चन में कौन कौन से ऑप्शंस करेक्ट हैं? ए, बी एंड डी। हमारे पास जो डाटा था मेमोरी बेस्ड वो हमने लिखा है, उसके अकॉर्डिंग आंसर किया है। आगे बढ़ते हैं, नेक्स्ट क्वेश्चन देखते हैं। Find the Laplace transform of x1t convolution with x2t, where x1t is u of t minus 2 and x2t is t into ut. बेटा t into ut का मतलब कौन सा सिग्नल है? रैम्प सिग्नल rt है। तो आपने यहाँ पर लिखा क्या? r of t कन्वोल्यूशन विथ क्या? u of t minus 2, ये है ना। अब आप इस तरह सोचिए, rt कन्वोल्यूशन विथ ut आप क्या लिखते हैं? पैराबोलिक ऑफ t लिखते हैं। तो rt कन्वोल्यूशन विथ ut कितना होता है? पैराबोलिक ऑफ t। यहाँ पर मैं लिख देता हूँ rt कन्वोल्यूशन विथ ut कितना होता है? पैराबोलिक ऑफ t। इसका मतलब क्या? t²/2 इंटू ut। अच्छा, अब आपने इन दोनों में से एक फंक्शन को 2 सेकंड का डिले प्रोवाइड किया, तो प्रीवियस रिजल्ट को भी 2 सेकंड का डिले प्रोवाइड करोगे। तो प्रीवियस रिजल्ट क्या है? पैराबोलिक ऑफ t, 2 सेकंड का डिले, तो पैराबोलिक ऑफ t माइनस 2। फिर क्या लिखते? t माइनस 2 होल²/2 इंटू u ऑफ t माइनस 2, ऐसे लिखते। अब हमें क्या लिखना है? लैप्लास। तो आप इसी पर क्या अप्लाई कर दो? लैप्लास ट्रांसफॉर्म। तो हमें लैप्लास किसका मिलेगा? जो भी रिजल्टेंट सिग्नल है। सपोज रिजल्टेंट सिग्नल इज बाई टी, ठीक है, तो वाई ऑफ एस लिख रहे हैं, कैसे मिलेगा? ये जो रिजल्टेंट पैराबोलिक ऑफ टी माइनस 2 आया है, इसका लैप्लास लिखो। पैराबोलिक ऑफ टी माइनस 2 मतलब t²/2 इंटू यू टी, इसका लैप्लास आप क्या लिखते हैं? 1/s। सपोज दिस इज पैराबोलिक ऑफ टी, देन पैराबोलिक ऑफ टी माइनस 2 टाइम शिफ्टिंग प्रॉपर्टी से, ठीक है। तो पैराबोलिक ऑफ टी का लैप्लास मैंने पैराबोलिक ऑफ एस अज्यूम कर लिया, पी ऑफ एस। तो पी ऑफ एस कितना है? 1/s³। 1 कितना है? s³। पैराबोलिक ऑफ टी माइनस 2, इसका लैप्लास क्या लिखोगे? पैराबोलिक ऑफ एस इंटू ई की पावर माइनस 2s, ऐसे लिखेंगे, ठीक है। तो टी को हमने टी माइनस 2 से रिप्लेस किया, तो लैप्लास में एक्स्ट्रा क्या मल्टीप्लाई करेंगे? ई की पावर माइनस 2s। तो कितना आया? ई की पावर माइनस 2s अपॉन s³। तो यहाँ पर हमने वाई ऑफ एस कैलकुलेट कर लिया, कितना आया? ई की पावर माइनस 2s अपॉन s³। अभी अगर मैच करोगे तो कौन सा ऑप्शन मैच होगा? ऑप्शन सी मैच होगा, ठीक है। आप लोग इसी तरह बने रहिएगा, ठीक है। अभी कुछ और भी क्वेश्चंस हैं सिग्नल के, वो अब नवीन सर सॉल्व करेंगे।
Thank you, Rohit sir. Everyone. Next question is given as impulse response of an LTI system is given as h of t is equal to e power minus 2t into u of t. The system is asking about the system, what the system it is present. Now just see here, it is given as h of t. So when you talk about h of t is equal to e power minus 2t into u of t, talking about the causality, impulse response is given, asking about the causality. Because of u of t, you know that h of t value is going to be greater than, when t is greater than 0, is not equal to 0. Okay. h of t is equal to 0 when t is less than 0, which will give you the condition called as the causal condition. The sketch for this one we got like this, equal to t, and this value is equal to h of t, is as shown in rho 0 and 1 e power minus t into u. That is only on the positive side of the time t, it to be called as a constant. It is absolutely integrable. Talk about this one, it is absolutely integrable. If it is absolutely integrable, we know that it is said to be called as the stable system. So this system is said to be called the stable. So option is nothing but in causal and stable. So both causal and stable. Option B is the correct answer. So now going to the next question. So consider a signal x of t given as x of t is equal to e power minus 2t. If 99% of energy of x of t lies within b hertz, then the value of b is dash hertz, he was asking. What the value of b hertz is present, he was asking. If you see here, it is given as a question, that is energy present in, because of b hertz we are writing it in terms of radians, 2 pi b, okay, and that is going to be equal to 99% of energy present in x of t. Then we can tell like this, that is energy present in 2 pi b, that is going to be equal to 99% of energy, means we can tell like this is 0.99 times of energy present in x of t. So for this condition, energy present in 2 pi b in the sense means we are going to be using the formula 1 by 2 pi integral, that is the Parsells power theorem or LS energy theorem. So the value is present from 2 pi b, that is minus 2 pi b2 plus 2 pi b. So mod of x of omega whole square into d omega is equal to, so 0.99% of energy present in x of t. Energy present in x of t means integral minus infinity to plus infinity mod of x of t whole square into dt, the formula we are using. So now what you are trying to doing is using this condition, substituting the values, that is mod x of omega. So obviously you knows that x of t is given, that is x of t transform, Fourier transform is equal to x of omega. So e power minus 2t into u of t is given as 1 by 2 plus j omega, and for this expression we are trying to write down the value. So this is present as 1 upon 2 pi integral, the value is present from minus 2 pi b2 plus 2 pi b is present. Substituting the value of mod x of omega, that is equal to that of 1 by, so mod x of omega whole square, that is going to be given as omega square plus 4, because this is x of omega, mod x of omega is under the root of 2 square plus omega square, because of mod square getting the value like this, into d omega is present, and that is going to be equal to 0.99 times the value of energy. Energy present is equal to from 0 to infinity, so e to the power of minus 4t into dt is. So when you solve about this value, that is going to present as, we can write like this, 1 by 2 pi integral 0 to 2 pi b, additionally 2 we are getting because of the symmetry even. So this 2 and 2 will cancel out, and the d omega divided by omega square plus 4, that is equal to 0.99. Energy present in this signal is equal to e power minus 4t divided by minus 4. The limits are from 0 to infinity by 4. So hope you understand it, and now we can write the value that is equal to 1 by pi. So integral, and this value is equal to that of 2 square. 4 can written as 2 square. You need to understand that is going to be given as omega square plus 2 square. So this is going to present as 1 by 2 tan inverse of omega by 2 present. The limits are present from 0 to 2 pi b, and that value is equal to that of 0.99 divided by 4. So this 2 pi will comes to other side, and this value is equal to that of tan inverse of, by substituting all the values, by calculating it, we get 2 pi b by 2, and that is equal to 0.99 by 4 into pi. We'll cancel out here times and by b. So calculate for 2 and 2 cancel, therefore pi b, the value of pi b is equal to that of tan of 0.99 pi by 2, and this value of b we are getting, pi b, we are getting approximately 63 point, the calculation, that is equal to 63.56 is the value we are getting. 63.56 is the value we are getting. So what is the value of B? Finally, the value of B is equal to 63.56 upon pi is the value here. So that's the final answer of B we are getting, which is going to be present. Check with the options. So it lies in between 63 by pi less than B less than 64 by pi. In between the value is present. So option B is the correct answer. So these are the questions asked from signals and systems. Okay, these all are the memory based questions. Okay, so hope the next subject will follow you. Thank you.
Good afternoon, dear students. This year from network analysis, 5 questions were asked. You see the difficulty level, it is easy to moderate. And out of the 5 questions, we got information regarding the only 4 questions. Come to the first question. Now, in this example, what is your requirement is the ABCD parameters. Get this ABCD parameters for this one, we can go for the different approaches. One of the approach for this one is as per given network, go for the any equations, go for either KVL or KCL. Then after, as per the required parameters, rearrange that one. So for this particular example, what is the requirement is the ABCD parameters. What is ABCD parameters? Standard equations are the V1 equal to AV2 minus BI2. What about this other equations? I1 equal to CV2 minus DI2. Now, for this particular example, from the network itself, we can conclude it is the loop 1 and the loop 2. That means simply we can go for the first respect to KVL equations. As per this 2-port network, in the input side, let us assume voltage is a V1 and the current of this one is a I1. In the other port, voltage is a V2 and the current is a I2. Now let us write the KVL equation correspond to loop 1 and correspond to loop 2. Now first let us come to the loop 1. Correspond loop 1, what is the input voltage? How much? V1. That I1 circulates in the 1 and the 1. What is the total resistance? Is the 2I1 plus. In this 1 ohm resistance, I1 is the downwards, I2 also downwards. Both are in same direction. For this one, give the name as the equation 1. Come to second one. What is the voltage? This is the V2. That I2 circulates in the 1 and the 1. Total resistance is the 2I2. I1 is downwards, I2 also downwards. Both are in same direction. You can write like this. Now it is a second equation. Now we got the KVL equations. Let us concentrate on the standard equations. What is the one of the requirement of the V1 in terms of V2, I2? V1, but we got in terms of the I1 and the I2. Now what about this other one is I1 value in terms of V2 and I2. You observe this equation 2. By rearranging this equation, can you separate the I1 value here? I1 equal to, we can write this V2 minus 2I2. Give the name as the equation 3. Now let us compare the coefficients. Let us compare give the name for this equation 4 and equation 5. If you compare this equation 4 and this equation 3 coefficients, now V2 coefficient is C. What is the V2 coefficient is 1. That means we can conclude as a C is equal to 1. Come to the D. I2 quotient is a minus D. Whatever this I2 quotient minus 2. That means what the D is equal to 2. Two parameters are completed. Come to the other two parameters. Now to get the other two parameters, let us substitute this equation 3. Let us substitute this equation 3 in this equation 1. If you do the substitution, now this I1 replaced by the equation 3. If you simplify this equation, we can write this as the V1 equal to 2V2. If you simplify this one, we write this as minus 3I2. Give the result of this one some equation 6. Now let us compare the quotients. Let us compare the quotients of this equation 6 and equation 5. V2 quotient is A, but the V2 quotient is a 2. That means what is the A is equal to 2. Come to the B. Now if you compare the quotients, what about B equal to 3? Now these are the ABCD parameters for a given network. Okay. Come to the other one. Now correspond this question, we can solve this problem by using different approaches. We can go for the nodal analysis, or we can go for superposition theorem. Any method you can apply. You can go for the nodal analysis, or we can go for superposition. Any method you can apply here. Now for this particular example, directly that balance bridge concept cannot be applied. Reason is correspond balance bridge in the diagonal points, only one source is required. But for this particular example, in the one diagonal point voltage source is present, in the other diagonal point current source is present. That means directly we cannot go for the balance bridge concept. That's why to solve this problem, if necessary, you can go for superposition theorem or nodal analysis. I am taking the help of the superposition theorem. Correspond to superposition theorem, come to the case 1. In the case 1, let us activate the current source. In this current source is activated, that voltage source position replaced by the short circuit. In the question, what is asking the V0 value? Give the MSM V0 dash. One kilo ohm. Now let us simplify this network. In this example, how this 1K and 1K both are in the parallel. What about this 1K and 1K both are in the parallel? Now equivalent is 1 by 2, equivalent 1 by 2. Again if you observe here, this 1 by 2, 1 by 2 both are in the series. 1 by 2, 1 by 2 both are in series. That means if you draw the one more simplified figure, now we get like this. Now for this particular example, this entire current is go to this branch. Voltage of this entire branch, voltage this one both are same. But the total resistance is the 1 kilo ohm. But the current is a 1 milliampere. 1 kilo ohm, 1 milliampere. If you multiply these two, what the voltage this one how much here? 1 volt. Voltage is 1 volt. It is the response correspond to the current source. Response correspond to current source. Come to the second case. In the case 2, let us activate the voltage source. When the voltage source is activated, whatever this current source is the open circuit. Now in this example here, in this diagonal point it is open circuited, one diagonal point voltage source is present. Now we can use the application balanced bridge. We can use the application balanced bridge. Here what is the requirement is the voltage across this one, V0 double dash, V0 double dash. Now correspond to this balanced bridge, voltage across this open circuit is equal to 0. Simply I am using application balanced bridge. That means here V naught double dash equal to 0. Finally, with respect to superposition theorem principle, the total response equal to V naught dash and V naught double dash. Then what is the total voltage is equal to 1 volt. The total voltage is 1 volt. Okay. Remaining questions are explained by the Naresh sir.
None. So thank you, Kiran sir. Now this question is given based on the resonance. This RLC circuit at resonance ke time par is asking about the average power consumed by the circuit. Here the current IL plus IC is equal to 0. Whenever at resonance ke time par IL plus IC is equal to 0, the total current will be flowing through the resistance only. So the power is equal to P is equal to IRMS square into R. Here the RMS value of the given is a 6 by root 2. If it is suppose given ampere, 6 by root 2 whole square into R. R value is 1 kilo ohm. That is 36 by 2 into 1K. 18 kilowatts. If it is given a milliamperes, the kilo will be going to cancel. But according to the given data, here the answer is 18 kilowatts average power consumed by the resistance. The next question is given theta plus theta 1 plus theta 2. I think is theta 1 is here. The current to the this branch RC branch and R2 theta 2 is here. This total angle will be 90 degrees. Then what is the RL into RC values? So what is now here the theta 1 is equal to, you can write the current will be tan inverse of XC by R plus tan inverse of XL by R is equal to 90 degrees. If apply tan A plus B, apply tan A plus B formula, here tan A tan B by 1 minus tan A tan B. So when it is going to 90 degrees, this value must be equal to 1 hona chahiye. Just substitute A value is here 1 by omega CR and 1 by omega LR. This will be RC, this will be RL. So after that, you get a now RL into RC is equal to here L by C. After completion of this, you get a RL into RC is equal to L by C. Just L value and C value both are same. So the answer is RL into RC is equal to 1 is the answer for this question. Okay, thank you.
All the students, today electronics engineering These are memory based questions, reasoning and aptitude. We have 3 questions and people are telling it is easy and moderate. This all will be memory based questions. Just verify the answers. So, very first question is a logarithm. We have done many things in the logarithm. It is one of the problem. See what is say that yesterday also given problem log y dividing by log p 1 by n. Second one log p comes to denominator base log y 1 by n. So when writing denominator 1 by n log p, this becomes 1 by n log y. So this will be cancellation. See, this will be cancellation. Log y cancel, log p cancel, 1 by n square. That n square was numerator, positive integer n is equal to 4. Logarithm part of numerical estimation you have done in the classroom, and it is not a complicated problem. It is one of the memory based problem. We come to second one. So it is the perimeter of the square. What is the perimeter of square? Sum of all the sides. Just you can take here they given P1 plus P2 plus P3 plus where K is equal to given length. Let us take K is equal to 1, 2, 3, 10. If we take K is equal to 1, perimeter is equal to 1 plus 1 plus 1, 4. If we take K is equal to perimeter 2 plus 2 plus 2, 8. Similarly, K is equal to 3, perimeter 12. K is equal to 10, perimeter 40. Sum of the perimeters 4 plus 8 plus 12 plus 16 plus goes up to 40. What you can take common? 4 is common. It is nothing but sigma n. What is the sigma n is equal to sum of the sigma n into n plus 1 dividing by 2. Sigma 10 into 10 plus 1 dividing by 2. You have taken that is equal to 220. It is nothing but perimeter of the sum of all the squares. We take K is equal to 1, perimeter is 4, K is equal to perimeter 8, K is equal to 3, perimeter 12. Similarly, K is equal to 10, perimeter 40. We can take 4 is common, sigma n, that is nothing but sigma 10. This is one of the question. Come to third one. So it is this type of things given 2018 also. Area of the inner circle, area of the outer circle. So what is the remaining part? Area of the outer circle minus area of the inner circle. First, please go through what they given. L is equal to land, W is equal to water. L is how many times? 1, 2, 3 times. So water how many times? 1 to 3 times. So what is the radius? I have taken AB is equal to R1, AC is equal to R2, AD is equal to R3, A is equal to R4, and R5, R6. What is the first circle? R1 is equal to area of the circle pi R square. That is nothing but R1 square. What is the meaning of R1? 2.5. When you come to sum of the land places, what is sum of the land places? This I have taken like this. This is equal. See, this I have taken L1. This is called L2. It is called L3. Sum of the land areas. What is the L1 plus L2 plus L3? Where L1 is nothing but pi R square. L2 is equal. So outer circle minus inner circle. R3 square minus R2 square. L3 is equal R5 minus square R square. So it is nothing but L1, L2, L3. It's not complicated, some time takes. Similarly, Y is equal, W is equal to water. What is the water is equal to? Water is equal to area of the water, that circle. R2 minus R1, R4 minus R3, R6 minus R5. By calculation 104 pi. So this area 78.25. Ratio of the land to the water is equal, we are getting 0.75. This problem not complicated, simplifying some time takes. So these 3 problems we got it by memory based questions. So if you have any other questions, please send to me. And it's not complicated. So people are telling some time takes. So that is area, maybe time taking, but it's not more time taking, maximum 2 minutes you can able to complete. So other questions, first 2 questions will be direct answers. Okay, thank you all of you. All the best. If you have any other questions, please send to us. Okay, thank you. 0.75, right. Answer is 0.75, very good. So thank you for all.
Very good evening, dear students. I hope you have done very well in today's GATE exam. So let us discuss the questions related to computer organization. So this question is, the starting address of a memory of 250 kilobytes is given. So the given memory is 256 kilobytes and the starting address is given as 500. And the question is to find out what is the final location or final address of the memory location. So therefore, the relation what we have between final and initial address is final address minus initial address plus 1 equals to capacity of memory. But here the capacity of memory we have to consider by default it is in the form of bytes, right. So if you observe in the LHS side and RHS side, this is in the hexadecimal form. Like, so what is the final address? We don't know, x minus what is the initial address? It is given as 2500 plus 1. So if I can observe here, it is very simple. Like this is in the hexadecimal form. So capacity should be written in the form of hexadecimal form. So how do you write this? This capacity of memory, that is 256 kilobytes, right? So forget about this B. B is already in the form of bytes, right? So how many addresses are there? 256k. So 256k means 256 into 1024. 1 kilo is equals to 1024 in terms of binary, right? So if you multiply, you'll get some figure 262144. So if you convert that value into hexadecimal, you'll get 4000. So that is the main thing you should follow. So you should not write 256k into again that bytes, right? Fine. So this is the relation. So what is the value of x? Very simple. X is equals to 400h. We are writing in hexadecimal form. So minus 1 plus 50. So this value is simply, so it is in hexadecimal form we are writing to make it simplified. So it is 3f f f h. This is minus 1 plus 250. So if you add this value, you will get if you add this value, that is 3f f f f h plus 50. Okay, fine. The value is f. This is 15 plus 5, 20. 20 is a decimal value. If you convert 20 into hexadecimal, it is 14h, right? So how, if you multiply these two in decimal, convert into hexadecimal, you'll get this one, right? Fine. So it is 1441, 1 plus 15, that is 16 plus 2, 18. 18 means again it is 12h1, that is 424ff. This is the correct answer. Okay, right. So that is how we have to find out the ending address. So EFF plus simply 50. This will result in the address called as 424ff. Okay, right. This is the answer for the given question. The next question. The next question is, number is given in decimal form 47. You have to find out what is the tens complement of this data. For example, in any number system, if R is taken as base of the number system, then R's complement is equals to R minus 1's complement plus 1. Simply basic level question, very simple. So R minus 1. So what is the value R now? R is equals to 10. So 10's complement. What is 10's complement now? So 10's complement is equals to 9's complement plus 1. So therefore we can write 10's complement equals to 9's complement plus 1. So what is 9's complement? We have to subtract the digits from 9, then add 1. Right. So here a 2-digit value is given. If it is some 0 4, then you can take 3 digits also, doesn't matter. So 2 digits, for example, say 9's complement. What is 9's complement? Subtract this 47 from 9 first. Okay, so what is the value? 9 minus 7, 2, 9 minus 4, 5. 52 is the 9's complement, right? That is 9's complement. So from this you have to add, for this value you have to add 1. So 52 plus 1, that is 50. So this is the 10's complement. Okay. So in 2's complement in binary, what we do? 1's complement plus 1. So same thing. 2 is the base, R minus 1. 1's complement plus 1. In the same way, R 9's complement plus 1. So 53 is the answer. If you take 3-digit value, it is 953. Okay, fine. Right. So this is the solution. Thank you so much.
Yeah, good afternoon, students. Communication systems questions I'm going to take up, and I came to know that around 7 questions came from communication systems. 5 questions are 2 marks, and 2 questions are 1 marks. What I came to know, this is the information what I got from the students. So I'm going to solve some questions for which I feel like the data was received properly. The remaining questions I feel like the data was not received properly. The data is not complete. I'm not going to take up those questions. So vice after a week, we will get a complete paper, official gate paper. Then I will provide the detailed solution. Okay. Now I'm going to solve the questions. The questions which I felt like the data received properly, I'm going to solve only those questions. Okay. So this is quite easy question, and this is about 16 QAM, and the bit rate here, and we have to find the minimum bandwidth. We need to find out. I felt this is going to be minimum transmission bandwidth. Okay. So what is the minimum transmission bandwidth means? What is the minimum channel bandwidth required to transmit this signal? So this is minimum transmission bandwidth. So this is RB upon log m base 2. The bandwidth of MRA PSK and MRA QAM will be same. That minimum bandwidth will be RB upon log m base 2. So RB is given 4 into 10 power 6, and this is log 16 base 2, and this is 10 power 6 hertz. This will be 1 megahertz. And I think they're given a question like you need to find minimum transmission bandwidth in megahertz only, then 1 will be the answer. Okay. Yes. I hope you done this question. This is a pretty straightforward question. This is. And this question here, EB upon N naught is given. This capital N naught, of course. And find probability of error for QPSK we need to find out. And here I think in the question they're given ERFC of U, how to find the value of this. So they're given that e power minus U square upon U root pi. Okay, this is also given in the question. Yes, the probability error of QPSK, this is same as probability error of BPSK. As in the classroom I said it. The D mean for BPSK and QPSK will be same. So probability error is also going to be same. The probability error will be Q of root over 2 EB by N naught. It is same as probability error of BPSK. And yes, it is given ERFC of U, how to find this value. This is given in the question. So if you write this Q function in terms of ERFC function, so आपको याद है तो QX is half ERFC of X by root 2. So from that, so this is half ERFC of X by root 2. This is what you will get. And this is half ERFC of root over EB upon N naught. This is given 8.4 dB, and the corresponding normal value is this is 84. This is, yeah, so this will be half ERFC of this will be 6.91. Okay, so try to find this value ERFC of 6.91 upon 2, where you can use this result which is given in the question, and if you substitute, and it comes to be around 0.01. So this is 10 power minus 2. Okay, so 10 power minus 2, so it looks to be the option is correct. Okay, so this 0.01 is what you are getting almost. And if you see this question, this is about finding the channel capacity. It is also a straight question. So here the bandwidth is given. This is 1 megahertz. Signal power is given S. It is minus 80 dBm. If it is just given minus 80 dB, this is 10 power minus 8 hoga, the corresponding normal value. But it is given in dBm, milli that is, so into 10 power minus 3 you will get corresponding normal value. Okay,
Even if you write this is 10 power minus 8, so answer is you're going to get same only. Here also if you write, okay, if you don't consider m here, in KT also if you don't consider m, so means in finding channel capacity B log base to 1 plus S by N, finding that S by N mm will be cancelled. So the answer is going to be same you will get. Even if you consider this is dB, this is dB, the answer you are going to get same only because mm will be cancelled. Finding S by N, that milli will get cancelled. And channel capacity को find करना है. So C is equals B log base to 1 plus S by N, and N if you see, so N is equals KTB. For white noise power, this will be KTB. I given this formula in the regular classroom. KT is equals minus 174. So this is, if you convert to normal, this is minus 17.4, corresponding normal value. This milli is given, so it is 10 power minus 3. Okay. It is KT, this is. B is how much here? Bandwidth is 1 megahertz. This is 10 power 6. Okay. Then channel capacity को find करना है. C is equals to B log base to 1 plus S by N. So B will be equals to, this is 1 megahertz, and this is log base to 1 plus. S is equals to, this is 10 power, this is minus 11, and N will be equals to, it is 10 power, this is minus S. So how much you will get is, it is P, so minus 14.4. Okay, so this will be equals to 1 m, and log base to 1 plus, it is 10 power 3.4. Okay, and if you simplify it, yes, it comes to be 11.29 Mbps is what you get. Okay, so which option is correct? Is the B is 1 megahertz only. This is the channel capacity, you got 11.29 m. So from the given options, it will be C greater than 3B, I can say. It will be the correct answer. If you see one question here, this is about Hamming code. 7, 4, 1 Hamming code, it is N, A, T min. This is okay. And bit error rate. Okay. So what is the probability of error in a single bit error rate? Bit error probability, or it is also called as a bit error rate, that is 0.1. Okay. Then probability that the decoder will fail to decode the received code word properly. Okay, so when I can say, okay, the decoder is decoding the received code word properly, when we can say the decoder is the receiver is decoding the received code word properly is if the receiver is managed to get the original transmitted code word back. Means if the received code word, if any errors are there in the received code word, it should able to correct those errors, and it should able to get the original code word back. Then I can say the receiver is decoding the received code word properly. And here the question kya hai ki what is the probability of the receiver, or I can say decoder, is failed to decode the received code word properly. Okay, so actually if you able to recall what is Hamming code, okay, Hamming code is basically LBC only, linear block code, but provided some conditions are satisfied by LBC, then you can call that LBC as Hamming code. And what is Hamming code? Basically it is a single error correction of perfect code. Okay, single error correcting perfect code को हम basically Hamming code बोलते हैं. Means Hamming code is basically able to correct single error only. It is having a limited capability of correcting single error only. Then what you can understand is in the received code word, if single error hai to, okay, then I can say that receiver is able to correct that single error, and it will be able to get the original transmitted code word back. Okay, so what is the probability of decoding the received code word properly? Okay, what is the probability of
okay, PC I'm writing, okay, probability of getting the original transmitted code word back. Okay, what is the probability of, okay, getting the original transmitted code word back is, what I can say is, okay, if there is probability of, okay, no error plus probability of 1 bit error, okay, means in the received code word, okay, if no error is there, if there is no error in the received code word, or if there is 1 bit error in the received code word, okay, then the receiver is able to correct that error and it is able to get the original transmitted code word back. So what is the probability of okay, decoding the received code word properly? Decoding the received code word, when it can able to decode the received code word properly, if there is no error or if there is 1 bit error, then I can say the receiver is able to decode the received code word properly. I'm finding it. Then what is the probability of okay, the received code word is okay, not decoded properly? Then that is 1 minus PC. Okay, the receiver is failed to decode the received code word properly, that is 1 minus PC I can say. If you find this is 1 minus PC, first if you find PC, what is the probability of no error? No error means this is okay, if 7 comma 4 comma 1 means how many, the code word is having how many bits in it? 7 bits in it. The code word which is transmitted is having 7 bits in it. So among transmitted 7 bits, okay, what is the probability of 0 errors? Okay, when n bits transmitted, aapko yaad hai to, what is the probability of getting r errors in the received code word? Okay, that is NCR p power r 1 minus p power n minus r. Okay, here 7 bits are transmitted. Okay, and what is the probability of 0 errors in the received code word? So this is 7C0, okay, NC0, p power, p here is nothing but bit error rate. So what is that? 0.1 power. It is actually, the formula is NCR p power r 1 minus p power n minus r. N bits transmitted, what is the probability of getting error in r bits? When 7 bits transmitted, what is the probability of getting error in 0 bits? So 7C0, 0.1 power 0, so 1 minus p. 1 minus p will be 0.9. Okay, here p is nothing but 0.1. P is bit error rate. So this is n minus r, it is 7. Okay, plus. So 1 bit error. So when 7 bits transmitted, probability of getting error in 1 bit. So it is 7C1, 0.1 power 1. This is okay, 0.9 power. This is 6. This will be. And this is, yes, 0.9 power 6. Yeah. So if you compute this, so it comes to be around 0.15 is what you'll get. What is the probability of decoder is failed to decode the received code word properly? That is 15% chances are there for that. Okay. So first we know that Hamming code is all about, it is able to correct a single error. Okay. So if the received code word may single error hai to, okay, so no error, or I can say single error hai to, then it is able to correct that error and it can be able to decode the received code word properly. And what is the probability of it is failed to decode the received code, failed to decode received code word properly? Okay, that is 1 minus PC. So this is 0.15 what you will get. It's a good question, what I feel like. So some more questions also. I got a partial information about the remaining questions. So but I'm not going to take up those questions until and unless, okay, complete information is received. It's better not to proceed with those questions. So let's wait for the actual gate paper to come, and we will see what actually the response is going to be, the answers going to be for those questions. So I feel like it will be, looks to be moderate only, not tough. The questions what we solved, these are not tough, like, okay, these are within the reachability only. Okay. So I hope you done well, okay, and all the very best, guys. Thank you.
Hello dear students, so hope you have done the mathematics questions very well, but 1-2 questions are little lengthy, but you can do it, right. Coming to this question, see, this is linear algebra question, how simple question it is, right, very simple question, saying that the determinant of A is not equal to 0, so finding the determinant of this matrix, okay, then mod A, if you find it here, that is of what do you get here, it is, take it as a plus minus plus, right, the determinant here 2 times of 3b, okay, minus 1 time of minus 1 time of d, okay, and plus 1 time of a plus 3 is equal to not equal to 0, not equal to 0. This is what it is the case. So then you can see that it is 6b minus b. It is how much it is? 5b. Okay, and then plus a plus 3 equal to 0 here. So a plus 3 is equal to, so this one you are going to 6b minus b, it is 2 into 3b, that is 6b, and minus 1 into here, I think let me tell you whether this is the right one or wrong one. Achar 211130 minus 1 AB. Okay, fine. So if this is the case, you can see that 5B then plus A and plus 3. So plus 3 not equal to 0. So if this is the matrix, so this is the condition we are arriving. Let us check with the options and see that whichever satisfies this, it is the correct answer here. But if the matrix is this one, so I don't know, please all of you check this matrix here. If this matrix is 1, 2, minus 1, okay, 2, 2, 4 and 0, A, B. अगर मैट्रिक्स ये है तो आपको मिलेगा डिटर्मिनेंट ऑफ ये नॉट इक्वल टू 0 के लिए, तो आपको मिलेगा ए 3a इज इक्वल टू माइनस बी, 3a इज इक्वल टू माइनस बी मिलेगा. तो आप चेक कर लो बेटा, आपका मैट्रिक्स ये था और ये था. अगर ये मैट्रिक्स था है तो ये कंडीशन आएगा, अगर ये मैट्रिक्स के लिए तो ये कंडीशन आएगा. तो आप एक बार आपके हिसाब से जो याद है एक बार देख लीजिए, ठीक है. तो एनीबडी पहले वाली भी मैट्रिक्स है. अच्छा, पहले वाली मैट्रिक्स है तो ये कंडीशन आएगा. जस्ट यू हैव टू चेक विद द ऑप्शंस, check with the options, whichever satisfies, that is the right answer here, right. Next question you can see this one, it is a calculus question beta. तो ये डबल इंटीग्रल क्वेश्चन है कि डबल इंटीग्रल में हम इसको ऐसे करेंगे, तो ये डबल इंटीग्रल ऑफ एक्स स्क्वायर प्लस वाई स्क्वायर डी एक्स डी वाई और ये एक -1 डी एक्स डी वाई. आपको पता है ये 1 डी एक्स डी वाई क्या होता है बेटा, ये एरिया को रिप्रेजेंट करते हैं, राइट और नॉट, एरिया ऑफ दिस स्क्वायर हियर. तो दिस इज द स्क्वायर वी हैव, तो एरिया ऑफ दिस स्क्वायर, सो एरिया ऑफ दिस स्क्वायर क्या होगा ये, दैट इज √2 इंटू √2, तो ये हो गया 2, राइट. सो बट इसका क्या होगा, इफ यू वांट टू फाइंड आउट दिस, तो डबल इंटीग्रल आर एक्स स्क्वायर प्लस वाई स्क्वायर आपने करना है कि dy dx. बट यू जस्ट सी दिस here, we can take this limits in this way. All of you please observe, if you see this one, 0 to 1 you take vertical strip, okay, and 1 to 2 you take another vertical strip. Since there are two vertical strips are forming, so we have to divide the region into two regions like R1 and R2 here. So therefore, so that is given by here double integral R1. अगर मैं double integral R1 ये एक्स स्क्वायर प्लस वाई स्क्वायर है और डी वाई डी एक्स, राइट, एंड प्लस डबल इंटीग्रल ऑफ R2 एक्स स्क्वायर प्लस वाई स्क्वायर इंटू डी एक्स डी वाई है, ठीक है. तो इस तरह आप ले लेना. So once you get this one, let's take the limits of R1. What are the limits of R1? Y, x varies from 0 to 1, y varies from -x to +x. So 0 to 1 minus x2 plus x of x square plus y square into dy dx. plus, and here y is equal to 1 to 2 and x is equal to what? Sorry, यहाँ से और एक लिमिट्स आता है यहाँ पर और 1 second. These are the limits of x equal to 1 to 2 and y is varies from, this is what here y is equal to x minus 2, minus of 2 minus x. ये होता है बेटा minus of 2 minus x2 plus 2 minus x here, which is xy dx dy or dy dx, sorry, x square plus y square dy d, x square plus y square dy and dx here, correct? Now you know that this is minus x to x means you have to check whether the function is inside or even or odd. You know that this is completely even, तो ये इंटीग्रल बनेगा 2 टाइम्स बेटा, तो ये हो गया 2 टाइम्स ऑफ 0 to 1 एंड 0 to x, ठीक है, और ये x स्क्वायर प्लस वाई स्क्वायर इंटू डी वाई डी एक्स बनेगा, और ये भी 2 टाइम्स इंटीग्रल ऑफ x इक्वल टू 1 to 2 and then it is of 0 to 2 minus x and here it is of x square plus y square into y d, ठीक है। तो ये क्या हो गया ना, अब इसका आंसर क्या होता है एक बार चेक करो, इसका आंसर क्या होता है, इसका आंसर और इसका आंसर दोनों का इंटीग्रेशन कर लीजिए, तो यू विल बी गेटिंग दिस टोटल आंसर इज गोइंग टू बी 8/3, तो इसका पूरा आंसर आएगा बेटा 8/3, ठीक है, और इसका एरिया ऑफ द स्क्वायर कितना आया था 2 हियर, तो दिस वन वैल्यू इज द इंटीग्रल ऑफ दिस वन इज 8/3 minus the integral of this one is 2, so this becomes here 2/3, so the answer for this question is 2/3 है, right? So this is what the way you have to do it as per this. Now it's little time taking बेटा, generally gate examination में इस तरह थोड़ा सा लेंदी वाला पूछ रहे हैं, चलो right, you should have the patience to get the answers for this. And one more thing, this question is of a complex year, so यहाँ पर ये देखना है बेटा, ये मॉड्यूलस ऑफ z है, ठीक है, ये मॉड्यूलस ऑफ z है, ये डोमाइन है, पर अगर आप देखते हैं ना, अगर ये क्वेश्चन सही है, अगर ये क्वेश्चन मेमोरी बेस्ड है, तो मेमोरी बेस्ड क्वेश्चन सही है, तो इसका पोल होगा बेटा आयोटा एंड 2, तो दोनों सिंपल पोल्स है, ये कौन है कि दोनों सिंपल पोल्स हैं, अगर ये दोनों सिंपल पोल्स हैं तो ये इनसाइड है आउटसाइड है, दोनों की दोनों आउटसाइड है बेटा, तो बोथ पोल लाइज आउटसाइड, यहाँ अगर z इज इक्वल टू आयोटा है तो यहाँ पर क्या होगा आयोटा -2 माइनस आयोटा, तो ये तो मॉडुलस ऑफ 2 हो गया, वो तो ग्रेटर देन 1/3 हो गया, तो लाइज आउटसाइड हियर, आउटसाइड है, तो अगर ये आउटसाइड है, नॉट ओनली दिस z इज इक्वल टू 2 भी आउटसाइड होगा, यहाँ पर 2 माइनस आई, so this is also greater than 1/3 because 1 is greater than 1/3, so again outside C, so if every pole is outside, so we apply CIT by Cauchy integral, this one f of z dz क्या होगा बेटा सीधा 0, right or not, so this is the answer. If this is the question and these are the poles and this is the contour, then obviously this answer is 0 here, correct. So there is one more question has been given, but there is one more question has been given, तो ये देख लीजिए, ये समेशन है, तो this syllabus is there for exclusively electronic student, right, तो मैंने बोला था कि यहाँ आपको ये एक्सक्लूसिव है, तो यहाँ से क्वेश्चन आ सकते हैं, राइट तो एक बार देखो बेटा, यहाँ 2 सीरीज दिया है ऐसे एस बी करके, तो दोनों डाइवर्जेंट है कन्वर्जेंट है, ये पूछ रहे, ठीक है, आई एम नॉट हैविंग द एग्जैक्ट ऑप्शंस एंड एवरीथिंग, बट इतना तो यह है कि ये 2 सीरीज है और 2 सीरीज की कन्वर्जेंस डाइवर्जेंस के बारे में पूछ रहा है, राइट। So now if I look at this, most of the time if you have seen that when there is a power n points are there function में अगर power n है तो हम क्या करना है बेटा, nth root टेस्ट करना है, तो now limit n tends to infinity, nth root टेस्ट बोलते हैं, क्या बोलते हैं nth root टेस्ट, तो अगर nth root टेस्ट यूज करते हैं तो un to the power of 1 by n है, right, so then it is limit n tends to infinity n square to the power of n by here it is 2, but you know this value is going to be always 1 here, ये पूरा 1 हो गया as n tends to infinity, so therefore it becomes 1 by 2 बेटा, तो 1 by 2 क्या होता है कि less than 1, so when this actually the concept according to the nth root test So limit n tends to un old power 1 by n is less than 1, it means that the series is convergent. So therefore, the series is convergent here because the value of the limit is less than 1. तो convergent है. तो अगर ये convergent है बेटा, ये CGT है, CGT means convergent. और ये क्या है बेटा, this is a geometric progression ना, ये तो up to 512 है. So 512 can be understood as what, 2 power 9, ये 2 cube, ये 2 square है, तो ये 2 square, 2 cube and 2 power 9. So it is something like S9 or not. S9 तो some finite value है, तो मतलब ये convergent है, right or not? Yes. So this series is absolutely convergent. So both the series are convergent for this one. So as memory based, so these are the questions we had. So thank you. I hope you have done well in mathematics, right? Right. God bless.
Hello students, welcome to the Digital Electronics Solutions session. Here we are discussing the electronics branch gate solutions. Let us check the questions here. This is a question gave here. This is related to the JK flip-flop. In this JK flip-flop, they are asking like what will be the output frequency here. When inputs are floating, that can be treated as high. That means both these will be 1. And now, when both inputs are 1 for a JK. Hello students, welcome to the Digital Electronics Solutions session. Here we are discussing the electronics branch gate solutions. Let us check the questions here. This is a question gave here. This is related to the JK flip-flop. In this JK flip-flop, they are asking like what will be the output frequency here. When inputs are floating, that can be treated as high. That means both these will be 1. And now, when both inputs are 1 for a JK flip-flop, it is going to work as a toggle mode flip-flop, you know that. So then, here both inputs are 1, 1. Previously, assume that the 0. And one clock is applied, toggle mode operation, it will be 1. And one more clock is applied, it's going to be 1 becomes as 0. So that we are getting like one single clock. Here you observe for 2 input clock pulses, we got only 1 clock at the output. So it's going to be x by 2 will be the frequency if x is the input frequency. Actually, no need to discuss this much. When it is a toggle flip-flop, simply it's going to be the half, the division of frequency takes place. You can remember that. Within fraction of second, you can answer that. And let us check the another question here. Of course, this is a question related to the multiplexer. Multiplexer, the practical oriented, so many applications are going to be there for this one, you know that. That type of combinational circuit. And here the output is going to be like here, x bar, z bar, I naught. And here x bar, z, I1. This is so simply the expression based on that you can get that. xz bar, I2. And this is going to be xz, I3. So here for this for these inputs, this is I0, I1, I2, I3. So that here it no need for this one because it is 0. And remaining thing, this is 1 and this is 1. And this is going to be the y. Now this expression you put in this any K map, you will get the answer for that. This is so simple way you can get it. And check the another question here, third one. Here, it is a CMOS related question where it is going to be done so simply a logic trick what I explained previously in your classes. Here, this is the NMOS. We should focus for the short trick to apply on the NMOS. When these two are parallel, we are going to have this one is going to be A plus B. But when you are taking here this output where this is the PMOS here, it's going to be here A plus B bar. So it's going to be the NOR gate. So simply like that. So questions are so simply within the fraction of seconds to handle. You apply the short tricks what we explained in the class and then you'll get the answer. And this time it can be used for the other things like that, isn't it? Right. Thank you.
Hello dear students, welcome to the video solution of the GATE 2026 paper. So it is a memory based paper and we have received only 2 questions, so I will be solving it. Right, okay. Now the first question is find the cutoff frequency of rectangular waveguide supporting T10 mode having dimensions 0.28 into 0.14 inches, right? So it is a very simple question. We know that cutoff frequency of T10 mode, it is basically C upon 2A, right? Here A value is given. Now the one thing that you have to remember is 1 inch, it is equal to 2.54 centimeter, right? 0.54 centimeter. So just substitute this value. So this is 3 into 10 to the power 10, right, upon 2. A is how much? 0.28. Convert this into centimeter, 2.54, right? Now when you solve it, you will be getting 21.09 giga. That should be the. Now it depends upon the actual data. So whatever the data we have got, so based on that, I'm solving the question. Second question. Identify the type of polarization of the EM wave given. Electric field is given, and they are asking whether it is a left circular, right circular, and so on, right? So in this case, what you have to do is first put Z equal to 0. If I put Z is equal to 0, I will be getting electric field as E naught cos of omega t ax cap plus T naught of sine omega t ay cap, right? So obviously this is a circularly polarized wave because the amplitudes are equal and there is a phase difference of 90 degree, right? So phase difference of 90 degree you can see here. So it is a circularly polarized wave. Now whether it is left or right, what you have to do? So first of all, you have to take at t is equal to 0, omega t will become 0. So if t equal to 0, omega t is equal to 0, then what is the value of electric field? So t equal to 0, omega t will be 0. So you will be getting only E naught ax. Is it? Similarly, if I put t is equal to t by 4, right? Omega t is equal to pi by 2. So what is the electric field value? So pi by 2 means you will get only E naught ay, right? So what you can do is, now to find the polarization, let us say this is the x and this is the y. So z axis is out of the plane, right? And since it is a circularly polarized wave, so it is a circle. Now at t is equal to 0, it is at x axis. So this is at t is equal to 0 and this is at t is equal to t by 4, isn't it? T is equal to t by 4. So that means time is increasing in this direction, correct? So that means it is going like this. Now here what you have to check in this particular case, the wave is propagating in minus of z direction, right? The wave is propagating along minus z direction. That means the wave is going into the board, right? So this is nothing but the wave is going into the board and this is the right hand. So the answer will be RCP, right circular polarized wave. RCP, right circularly polarized wave, that is option B, right? So these are the two questions that we have got and this is a completely memory based. I hope you have done well in the examination. All the best. Thank you.